This lesson is about copper. Copper plays an important role in art regarding pigments. Copper is present in old pigments, so used from antiquity, like malachite, verdigris, azurite, and also even today it's present in modern pigments such as phthalocyanine, blue, the green. This lesson will explore how to identify copper, which in general is pretty fine because copper has a strong XRF signal, but we will focus in particular on the phthalocyanine pigments because in that case, since copper is present but in a very small amount, the signal is very low, so we need to change the filters in our X-ray tube. We find copper over here, 29. Let's see what are the pigments, at least in our pigment checker, that contains copper, so to evaluate which one to double check. We go in our class, then on the bottom we have in resources, we go in chemical elements in the pigment checker standard, and there it is. So from here we see basically this is a table where I input the main elements that constitute the pigment. So we are looking for cuprum, so copper, Cu, and we do the search, and so here we see first, second and third. So the main pick is copper for azurite, blue bise, Egyptian blue and so on. So these are the pigments that contain mostly copper. So we can choose azurite, we can choose malachite from here, and also from here I want to choose phthalo blue, where the main element is also copper. We start with malachite, the green pigments over here, then we will do azurite, and then we'll work with phthalo blue over here. The first test with this equipment, with the XRF spectrometer, could be to test actually a piece, this cube of copper. Then now we can go directly to measure the pigment checker, and we start with malachite over here. So malachite is there in a position and we do the acquisition. This is the spectrum we acquired from malachite. We have this large big peak, intense peak at 8 keV, and then we have another one smaller over here. Let's check in our table what are the peaks of copper. We now navigate our course, online course, so this is the main page, and we look here for our resources. We have XRF peaks of chemical elements. Okay, so we click here, and here we have the main elements that are important for art examination. So we go for 29 is over here, copper. So we see that K alpha, so we read from here K alpha and K beta. So K alpha for copper is 8 and K beta is 8.9. The examination of malachite is pretty easy because from the formula we see that malachite is a basic copper carbonate. So you see there is a copper over here in the formula, and there are few other elements. So there is the carbonate group and the hydroxide group over here, the ions, hydroxide ions over here. And that's all. So when we analyze malachite, there is a lot of copper. That's the reason why the peak with the standard acquisition parameter, the picker of the copper picker is so intense. Let's move to another example. Azurite, there it is. So we launch now the acquisition. This is the spectrum of azurite, so it's the red one over here. So we see basically the same kind of intensity, so the strength of the main K alpha peak is the same. Also we can read from here the number of counts. Azurite has actually more copper than malachite. Indeed, here we see 3 atoms of copper. For this acquisition, remember, we use the standard, the routine parameters. So basically kilovolt is 50, then the current we use 5 microampere. We use the same set of filter, first the tungsten, then the aluminum 1 millimeter thickness, and the acquisition time is 30 seconds. Now let's try phthalocyanine blue. Phthalo blue is over here, phthalo blue, there it is. We compare this spectrum, the red one for phthalocyanine blue, we compare it with malachite, the previous one. So we see now from the counts, but also from the noise in the spectrum, that the copper signal, so this peak over here at 8 keV, is definitely extremely much smaller. And this is because phthalocyanine blue contains copper, but the ratio is much smaller. Phthalocyanine blue is a copper phthalocyanine. So this is the formula. We have here just one atom of copper, which is surrounded by 32 atoms of carbon, 16 hydrogen and 8 nitrogen. In this kind of a molecule, the copper inside this molecule plays a little role in terms of the XRF emission, because it's surrounded by all the other atoms that will interact with the X-ray. So this is why in this kind of pigments the signal is much smaller. So when we do the examination on an object, we could actually miss the copper in it, because you see basically again over here in this acquisition the signal of copper is quite almost the same of the noise. It makes sense to try the examination changing the filters in the tube. Now we do the measurement of phthalo blue, but we change the filters. Remove the cover, then we unplug this one, the collimator with the filter. Okay, we remove the filter inside and we replace them with this one that is aluminum 1/4 of millimeter, so 0.25 millimeter. So we put this one back here in the collimator, this one back. There it is. This is the result of the examination done with the low keV setup, filters setup basically. So we are doing the acquisition. So these low keV parameters are used when we want to get the information for those peaks that are below 2 keV and roughly 10 keV. For elements that are in low concentration, so we need to really raise this information. We use the kilovolts in the tube is still 50. We increased the current, so we brought it to 50 microamperes, and now we, as a filter, we are using just 0.25 millimeters, so 1/4 millimeter of aluminum, and the acquisition is still 30 seconds. So basically now we see that the peak, this is copper before, so for still phthalocyanine blue. Now with this filter the peaks of phthalocyanine is much bigger. Of course here the scale here is different, so we are around almost 1000. Here we were just 10 counts, and we also now we see the K beta peak of copper. So this is actually very useful because we have a confirmation that that is the peak of copper, since we have both of them. Bottom line, trying to do the acquisition with also the low cave parameters is very important.